Howdy, my name is Paul Hubner. My team members are Courtney Burrows, Andrew Kaplan, Eugene Lee, and Orion Luce. We will be presenting our proposal for our final project in this video. Now, our original idea was to create a modified version of Battleship. Since then, our idea has changed to incorporate identification using an HSV camera and LiDAR to help the robot maneuver.
Howdy, I'm Orion Luce. So, for our project roles, both Andrew and I are going to be working as software engineers since we have to implement both the camera and LiDAR. Eugene's going to be working as a hardware engineer, putting everything together. Courtney is going to make sure everything actually works. And Paul's just generally managing everything. From the Gantt chart, you can see that most of our timeline is spent on putting together the software and the hardware, making sure that everything works in combination with each other. Once the proposal's due, the software will work on from the 26th to the 25th, which is almost a whole month. Right after that, we'll get to testing in the last 2 weeks, and finally the demonstration on the 6th.
The hardware used for this project is a LiDAR sensor, a HSV camera, a buzzer or speaker device, and the scuttle itself. The LiDAR is used to detect obstacles in the scuttle's path, and it allows the scuttle to avoid the obstacles on its way to its target. This can include static and dynamic obstacles. The HSV camera allows the scuttle to identify the different colored balloons that we will use for this project and track them. The buzzer or speaker will be used to indicate if the scuttle identifies an object in color. For example, the scuttle could play a note once it identifies the color maroon.
Obstacle avoidance implementation. We will use a LiDAR for obstacle avoidance. We will have a human walking around to provide a dynamic obstacle with a wall providing a static obstacle. We will be using an HSV camera to identify the balloon colors, with the balloons having a wide range of colors, avoiding similar colors, so the robot doesn't get confused. The idea that we're going with is a battleship-esque idea, where the humans will stand on one side of a wall and input into the robot a certain order for the colored balloons to be interacted with. The robot will then have to locate the various balloons in order, drive up to them, perform some interaction around near the balloon, and then locate the next balloon and travel to it.
We have many potential implementation options for our project. One idea from our object identification choices and one from our projectile launching choices will be chosen for the final design of the project. For our object identification, the robot will identify a target and travel to it. Our potential targets are balloons, colored cones, numbered markers, small ship models, or grid coordinates. For projectile launching, where the robot will launch a projectile from a specified distance at the identified target, our projectiles can be golf balls, darts, or Nerf darts.